The process of fabricating a PN junction begins with an N-type or P-type doped semiconductor, into which the opposite type of impurity is introduced. To understand how this structure works and what physical processes take place in it, a didactic model is used. The model consists of a P semiconductor perfectly matched to an N semiconductor. The P semiconductor has a much higher hole concentration than the N semiconductor. Therefore, holes from the P region will diffuse into the N region. Similarly, electrons from the N region will diffuse into the P region. The diffusion of electrons and holes creates a region depleted of free charge particles, leaving behind the ionized impurities from which these charge particles come. Thus, a region of positive ionized impurities and a region of negative ionized impurities appear in the PN junction. This special distribution of charges creates an electric field. The electric potential associated with these fields acts as a barrier that prevents the displacement of the electrons and holes. Equilibrium is reached when the diffusion current equals the drift current. The potential barrier is an obstacle for the diffusion current in the device. It is possible to reduce the height of this potential barrier by the application of an external voltage. This increases the electric current. By applying an external voltage from a battery, the height of the potential barrier in the junction is modified. If a positive voltage drop is applied between the P and N regions, the barrier height is reduced. A reduced barrier cannot prevent electrons and holes from diffusing across the structure. An electric current appears in the junction due to the diffusion mechanism. Under these conditions, the PN junction is said to operate under a forward bias. If the voltage is reversed and becomes greater in the N than the P region, the barrier height increases, preventing the electron and hole diffusion. The electric current is then negligible. In conclusion, the PN junction can only conduct in a single direction, giving rise to a current which increases very rapidly when the potential barrier is significantly lowered. Besides being present in countless circuits and electronic components, PN junctions can also be found in optoelectronic